Hi there. For this video, we'll be discussing how to simplify rational expressions. So let's go on to our first example. Let's have 5ab squared over 25a squared b. Now to do this one is similar to the division of monomials. So basically, we'll just write this one out in its simplest form. Or what I mean by that is we'll decompose the numerator and the denominator into its simplest parts. So for the numerator, we'll have 5 times a times b over 5 times 5, since 25 is equal to 5 squared, times a times b. After this, what we can do is we can cancel out the similar terms from the numerator and the denominator. So since we have a 5 here and a 5 here, we can cancel that one out. Also, we can cancel out the a out here. And lastly, we can cancel out the b out here. After those cancellations, we are left with b over 5a. And that is the simplest form of this rational expression. So I won't dive deep into this one anymore, but feel free to check out my division of monomials video for similar problems like this. Let's go on to this next example. Let's have 2x squared plus 4x plus 8 all over 10y squared plus 12y. Now for this one, what we can do is observe that the numerator has a factor of 2 in each of its terms, since 4 is equal to 2 times 2, 8 is equal to 2 times 4, and the denominator is the same. 10 has a factor of 2, since 10 can be written as 2 times 5, and 12 can be written as 2 times 6. So we can write this one as 2 times x squared plus 2 will be left. So we'll have 2x, and in here we'll have 4 over the denominator. We'll factor out the 2, so we'll have 2 times what's left inside is this one, so 5y squared plus this one 6y. And from here we can cancel out the 2, leaving us with x squared plus 2x plus 4 over 5y squared plus 6y. And notice that we can't really factor anything in here anymore, since if we try to, we can factor out the y out here, or this one, we might be able to apply the quadratic trinomial trick to factor it, but its variables is x and the variables here is y. So we can't really cancel anything out. So this is the final answer. So the main trick that we used here is to apply the common monomial or the common factor in simplifying this. let's have this third example. X plus 3 over x squared plus 6x plus 9. Now in the following examples, including this one, we'll really be needing our knowledge in factoring polynomials. In this example, observe that the denominator out here is a perfect square trinomial. Indeed, this is a perfect square, this is a perfect square. If we get their square root, that is x, this one is 3. Multiply this 2, 3 times x times 2, give us 6x, the middle term. So, let's move this one. With that in mind, we can write this one as x plus 3 all over by perfect square trinomial. The denominator is x plus 3 squared. And we can write this one as x plus 3 all over x plus 3 times x plus 3. Then, we can cancel out the x plus 3 out here, leaving us with 1 over x plus 3. And this one is the final answer for this problem. So in this problem, we applied the perfect square trinomial. Let's have this fourth example. We have x minus 3 all over x squared minus 9. Now in this example, observe that the denominator this time is a difference of 2 squares. Indeed, x squared is a perfect square. When we get it squared, it's x, and 9 is a perfect square. When we get its square root, it's 3. So applying this one, we can write this one as x minus 3 all over x plus 3 times x minus 3. Yep. There. And then, since there is an x minus 3 in the numerator and in the denominator, we can cancel that one out, leaving us with 1 over x plus 3. This is the answer. Let's have this fifth example. Let's have a squared minus ab plus b squared over a cubed plus b cubed. Now in this one, it might not seem clear at first, but this denominator out here is a sum of 2 cubes. We know that this one is equal to a plus b times a squared minus ab plus b squared. So we can write this one as a squared minus ab plus b squared all over a plus b times a squared minus ab plus b squared. We can cancel out this one in the numerator and in the denominator, leaving us with 1 over a plus b. This one is the answer. So this time, we applied the concept of sum of 2 cubes. Let's have this sixth example. Let's have x squared plus 7x plus 12 all over x squared plus 9x plus 20. Now for this time, we'll apply the factoring quadratic trinomial method. So let's move this one out here. And then, observe that the numerator, we can verify that we can factor this one into x plus 4 times x plus 3. For the denominator, you can verify that we can factor this one as x plus 4 times x plus 5. To verify this, we may refer to my factoring quadratic trinomials video. With this in mind, we can write this one as x plus 4 times x plus 3 over x plus 4 times x plus 5. Since we have a x plus 4 in the numerator and in the denominator, we can cancel that one out, leaving us with x plus 3 over x plus 5. And this is the answer. Let's go on to our 7th example. Let's have ax minus ay plus bx minus by over x squared minus y squared. Now for this one, we'll now try to apply the factoring by grouping method. Now note that the numerator, we can pair this one up out here, and we can factor out the a's out here, and for the second pair, we can factor out the b's out here. So the numerator will be a times x minus y plus b times x minus y over, for the denominator, observe that this one is a difference of two squares. So we can write this one as x minus y times x plus y. So we'll do that. We write this as x minus y times x plus y. Now from here, since we have an x minus y out here and x minus y out here, if we can treat this as one variable, we can factor this one out. So we'll have like x minus y here times a plus b. X minus y is the one that we treat as one variable, and then a plus b out here is the one left inside. Basically, what we did is we applied the concept of factoring by grouping over x minus y times x plus y. From here, we can cancel out the x minus y in the numerator and in the denominator, leaving us with a plus b all over x plus y. And this one out here now is the final answer. So we applied the concept of factoring by grouping in this example. Let's have one last example. Let's have x squared plus 6xy plus 9y squared minus z squared over x plus 3y plus z. From here, what we will do is we'll apply again the concept of factoring by grouping, but this time we'll group these three terms out here. From here, observe that this one out here is a perfect square trinomial. So you can verify that by perfect square trinomial, this one is equal to x plus 3y squared, copy the minus c squared, over, note that the denominator cannot be factored out anymore since we have different variables out here. So the denominator will become x plus 3y plus z still. Let's move this one. Oops. From here, observe that this one out here is a difference of two squares. With this in mind, we can write this one, or we can factor the numerator as x plus 3y plus z times x plus 3y minus z all over x plus 3y plus z. Now observe that if we remove the parentheses out here and out here, observe that we both have a x plus 3y plus z in the numerator and in the denominator. So we can cancel that one out. And so we are left with x plus 3y minus z. And this is the answer. Before I end this video, here are two exercises that you can work on. Exercise. So the first one is 6 minus x over x squared minus 36. The next one is y raised to 6 minus 1 all over 1 minus y squared. And forgot to put, but we consider this one to be negative. So these are the exercises that you can work on. So basically, to simplify rational expressions, what we do is we apply the knowledge that we have in factoring polynomials. So basically, in our examples, we try to run through in every factoring method, like the GCM, the perfect square trinomial, the difference of two squares, sum and difference of two cubes, factoring by grouping, and others. So yeah, that's it for this video, and feel free to comment down your recommendations, suggestions, and your answers and solutions to these exercises. So that's it, and that's all for this video.